So we have two functions here that are defined for certain points. I want you to think about it first, look at the values that are there, and see if you did g of f of 2, what value do you think you would get? If you did g of 2, what value would you get? So to start with g of f of 2, if we start on the inside, f of 2 would be right here. F of 2 is 0. So this inside f of 2, since f of 2 equals 0, and you don't have to write this, but this is just to help you see what's happening. Since f of 2 is equal to 0, then g of f of 2 is the same as g of 0, because I can replace that f of 2 inside with 0. And then g of 0, here's the function g. If you plug in 0, you would get 1. So that makes this equal to 1. And to connect this to what we were doing earlier, we would have two machines in a row. And you first put something into F and then put something into G. And the number that we're putting in is 2. So if you put 2 into the F machine, what would come out? A 0. And if that 0 then went into the G machine, what would come out is a 1. So g of f of 2 is equal to 1. Now what's sometimes confusing about function notation or composite functions is that you're sort of used to reading from left to right, right? So you see the g first and you might want to do that function first. But that's not what's happening. It's sort of like order of operations. You have to do brackets first. What's inside the brackets is f of 2. So that's why that f of 2 gets done first. Now that we've gone through that example, try the second one and check with the person on your left. So when you plug in 2 into g, do you see that you would get -1? So g of 2 is -1. And then -1 is equal to 2 again. Question number 4 for practice.